Check for optimal condition. For maximization, all Cj minus Zj values must be less or equal to 0, and for minimization, all Cj minus Zj values must be greater or equal to 0. Linear programming problem, simplest method. In this video, I'm going to explain how to solve linear programming problem by using the simplest method. See, there are many ways to solve linear programming problem, but in this video, I'm going to explain LPP by using the simplest method. Let's see the question. The question says, solve the following linear programming problem using the simplest method. Maximize Z is equal to x1 plus 1.5 x2, subject to 2x1 plus 4x2 is less or equal to 12, 3x1 plus 2x2 is less or equal to 10, x1 and x2 are greater or equal to 0. Recall that this is the objective function, this is the equation of the first constraint, and this is the equation of the second constraint. When solving LPP by using the simplest method, the first thing to do is to add slack variable s1 to the first constraint to balance the equation of the first constraint, and add slack variable s2 to the second constraint to balance the equation of the second constraint. Then add those two slack variables in the objective function with the coefficient of 0. This is what I mean. Maximize Z is equal to x1 plus 1.5 s2, subject to, look at the equation of the first constraint. So subject to 2s1 plus 4s2, you add the slack variable s1 to the first constraint. So here is 2x1 plus 4x2 plus add slack variable s1 is equal to 12. And for this equation of the second constraint, 3s1 plus 2s2, you add s2. So here is 3s1 plus 2s2 plus you add the second slack variable s2 is equal to 10. So add s1 and s2 to the objective function with the coefficient of 0. So here you add plus 0x1 plus 0s2. The next thing to do is to frame your initial simplest table. Here is my initial simplest table. We have the CBI, the CJ, the basic variables, the solution, and the ratio. Let me explain this table. The basic variables are the variables of the objective function. Look at the objective function here. Z is equal to x1 plus 1.5 s2 plus 0s1 plus 0s2. So the variables here are x1, s2, s1, and s2. So here we have s1, s2, s1, and s2. Cj are the coefficient of these variables. So the coefficient of s1 here is 1, 1.5, 0, and 0. So here we have 1, 1.5, 0, and 0. Then the next thing to do, how many slack variables do we have here? S1 and S2. We have only two slack variables here. So we write the slack variables here, x1 and x2. So what is the coefficient of S1 here? 0. We write 0 here. And what is the coefficient of S2 here? 0. We write 0 here. Then look at the equation of the first constraint. Here we have the coefficient of S1 is 2. Coefficient of S2 is 4. Coefficient of S1 is 1. There's no S2, so the coefficient is 0. So here we have 2, 4, 1, and 0. So for this first row, we have 2, 4, 1, and 0. And for the second row, look at the equation of the second constraint. We have 3x1, 2s2. There is no s1, and we have 1s2. So here we have 3, 2, 0, and 1. So here we have 3, 2, 0, and 1. Here is equal to, for the first constraint, here is equal to 12. So here we have 12. And here is equal to 10. So for here we have 10. The next thing to do is to find the Zj values. This is the formula to find Zj values. But here, I'm going to show you how to find Zj values with a simple method. So for this point, 0 multiplied by 2 plus 0 multiplied by 3 gives you 0. 0 multiplied by 4 plus 0 multiplied by 2 gives you what? 0. 0 multiplied by 1 plus 0 multiplied by 0 gives you what? 0. 0 multiplied by 0 plus 0 multiplied by 1 still gives you 0. After getting your zj values, the next thing to do is cj minus zj. So cj minus zj. Here, 1 minus 0 gives us what? 1. 1.5 minus 0 gives us 1.5. 0 minus 0 gives us 0. And 0 minus 0 gives us 0. At this point, after getting your cj minus zj values, we do the optimality test. So this is a maximization problem. And optimality condition for maximization, all cj minus zj value must be less or equal to 0. So all cj minus zj value must be less or equal to 0. So here we have 1, 1.5, 0, and 0. Here we have 1.5, which is greater than 0, and we have 1, which is greater than 0. So we have not reached the optimal solution. Then the next thing to do is, from cj minus zj, what is the maximum positive number? Here the maximum positive number is 1.5. So this column becomes your key column. Now, solution divided by the key column to get your ratio. So 12 divided by 4 gives you what? 3. And 10 divided by 2 gives you what? 5. What is the least positive number between 3 and 5? So the least positive number here is 3. So this now becomes your key row. The intersection between the key row and the key column now gives you the key element. So S2 is now the entering variable, whereas S1 is now the leaving variable. At this point, we frame the second simplest table. This is my second simplest table, and I call this table iteration 1. So from your initial simplest table, we have basic variables as S1, S2, S1, and S2, and cj values as 1, 1.5, 0, and 0. So they remain the same. So here we have X1, X2, S1, and S2. And the cj value is 1, 1.5, 0, and 0. So here we have 1, 1.5, 0, and 0. Then from the initial simplest table, look at the key column and look at the key row. So look at the entering variable and look at the leaving variable. So here S2 is the entering variable and S1 is the leaving variable. So here we have S2 and the coefficient of S2 is 1.5. So 1.5. S2 still remains the same. So here we have S2 and the coefficient is 0. Then to get the new values for this row, we use this formula. New values is equal to old values divided by the key element. So look at the old values for this row, for this key row. The old values here are 2, 4, 1, 0, and 12 divided by the key element, which is 4. So 2 divided by 4 gives us the new value for this position. 4 divided by 4 gives us the new value for this position. 1 divided by 4 gives us the new value for this position, and so on. So 2 divided by 4 gives us 1 over 2. 4 divided by 4 gives us 1. 1 divided by 4 gives us 1 over 4. 0 divided by 4 gives us 0. And 12 divided by 4 gives us 3. So to get the new values for this row, we use this formula. New value is equal to old value minus corresponding key column value multiplied by corresponding new value. Let me explain this formula. Old value, see, from your initial simplest table, look at the old values here for that row. 3, 2, 0, 1, and 10 multiplied by corresponding key column value. The corresponding key column value for this row is 2. So multiply by 2, which is the corresponding key column value for this row, multiplied by corresponding new value. The corresponding new values here are 1 over 2, 1, 1 over 4, 0, and 3. So to get the new value at this point, what is the old value at this point? 3. So 3 minus corresponding key column value for this whole row is 2. So 2 multiplied by corresponding new value is 1 over 2 is equal to, so 2 multiplied by 1 over 2 is 1. 3 minus 1 is 2. So the new value for this position is 2. Similarly, for this position, what is the old value in this position? 2. So 2 minus 2 multiplied by 1 is equal to 2 multiplied by 1 is 2. 2 minus 2 gives us 0. So for this point, the new value at this position is 0. For this position, what is the old value at this position? Is 0. So 0 minus corresponding key column value is 2 for this whole row. So 2 multiplied by, what is the new value? 1 over 4. So 2 multiplied by 1 over 4 gives us 1 over 2. So 0 minus 1 over 2 gives us minus 1 over 2. So here we have minus 1 over 2. For this point, what is the old value at this point? 1. So 1 minus corresponding key column value 2 multiplied by new value 0. So 2 multiplied by 0 gives us 0. 1 minus 0 gives us 1. So the new value at this point is 1. And for this position, what is the old value here? 10. So 10 minus 2 multiplied by the new value 3. So 2 multiplied by 3 gives us what? 6. 10 minus 6 gives us 4. So the new value at this position is 4. Now, after getting these two new rows, we now find the ZJ values. Recall how we found the ZJ values for the initial Simplex table. So we use the same method here. So 1.5 multiplied by 1 over 2 plus 0 multiplied by 2 gives us 3 over 4. 1.5 multiplied by 1 plus 0 multiplied by 0 gives us 1.5. 1.5 multiplied by 1 over 4 plus 0 multiplied by minus 2 gives us 3 over 8. 1.5 multiplied by 0 plus 0 multiplied by 1 gives us 0. 1.5 multiplied by 3 plus 0 multiplied by 4. 1.5 multiplied by 3 gives us 4.5 plus 0 gives us 4.5. Here the value is 4.5. Then the next thing to do is Cj minus Zj. So for Cj minus Zj, 1 minus 3 over 4 gives us what? 1 over 4. 1.5 minus 1.5 gives us what? 0. 0 minus 3 over 8 gives us what? Minus 3 over 8. And 0 minus 0 gives us what? 0. At this point, we now do the optimality test to check whether we have reached the optimal condition. Optimal condition for maximization, all Cj minus Zj value must be less or equal to 0. So here we have Cj minus Zj as 1 over 4, 0, minus 3 over 8, and 0. So we still have 1 over 4, which does not obey that condition. Therefore, we continue the process. Cj minus Zj, what is the maximum positive number in Cj minus Zj? The maximum positive number is 1 over 4. Therefore, this becomes the key column. Now, to get the ratio, we have to do solution divided by the key column. So, solution divided by the key column to get the ratio. 3 divided by 1 over 2 gives us 6. And 4 divided by 2 gives us 2. What is the least positive number in the ratio? The least positive number in this ratio column is 2. So now we have this as the key row and 2 as the key element. Now from the key row, x1 becomes the entering variable, whereas s2 becomes the leaving variable. To proceed further, we need to form a new Simplex table. Hey guys, at this point, if you haven't subscribed to my channel, I will love you to subscribe now and turn on the bell notification to get notified anytime I drop a new video. So here we have our new Simplex table, which we call iteration 2. From the last Simplex table, which we call iteration 1, the basic variable still remains s1, s2, s1, and s2. and the Cj values still remain 1, 1.5, 0, and 0. Note that the basic variables and Cj values remain the same throughout the solution. So here we have x1, s2, s1, and s2. And the value, the coefficient of s1 here is to 1, 1.5 for this one, 0, and 0. From the last table, this is the key column and this is the key row. So here is the entering variable, whereas here is the leaving variable. Therefore, S1 is the entering variable and S2 is the leaving variable. So X1 is here, which is the entering variable, and the value of S1, the coefficient of S1 here is 1. So here we have 1. S2 still remains the same. So S2 1.5. To get the new values for this row, which is the key row, we now use this formula. We use this formula. New value is equals to old value divided by key element. And here, the key element is 2. So, old values, which are 2, 0, minus 1 over 2, 1, 4, divided by this key element. So, for this point, 2 divided by 2 gives us 1. So, the new value for this point is 1. 0 divided by 2 gives us what? 0. Minus 1 over 2 divided by 2 gives us what? Minus 1 over 4. 1 divided by 2 gives us what? 1 over 2. And 4 divided by 2 gives us what? 2. Then, to get the new values for this row, we use this formula. New value is equal to old value minus corresponding key column value multiplied by corresponding new value. Let me explain this formula once again. New value is equal to old value. For this row, look at the old values here. 1 over 2, 1, 1 over 4, 0, and 3. So these values minus corresponding key column value. The corresponding key column value for this row is 1 over 2. So 1 over 2 multiplied by corresponding new value. So the corresponding new value is 1 for this first position. So at this point, to get the new value for this position, the old value here, which is 1 over 2, minus corresponding key column value, which is 1 over 2, multiplied by corresponding new value, which is 1. So 1 over 2 multiplied by 1 gives us what? 1 over 2. 1 over 2 minus 1 over 2 gives us 0. So the new value at this position is 0. For this point, the old value here is 1. So 1 minus 1 over 2 multiplied by 0. So 1 over 2 multiplied by 0 gives us what? 0. 1 minus 0 gives us 1. So here, the new value for this position is 1. For this position, the old value here is 1 over 4. So 1 over 4 minus 1 over 2 multiplied by minus 1 over 4. So 1 over 2 multiplied by minus 1 over 4. And 1 over 4 minus the answer gives us 3 over 8. So at this position, we have 3 over 8. So for this position, the old value at this position is 0. So 0 minus 1 over 2 multiplied by 1 over 2. So 1 over 2 multiplied by 1 over 2 gives us 1 over 4. 0 minus 1 over 4 gives us minus 1 over 4. So the new value at this position is minus 1 over 4. And for this position, the old value here is 3. So 3 minus 1 over 2 multiplied by 2. So 1 over 2 multiplied by 2 gives us 1. 3 minus 1 gives us 2. So the new value for this position is 2. After getting these two rows, the next thing to do is to get your ZJ values. So to get the ZJ value at this point, 1.5 multiplied by 0 plus 1 multiplied by 1 gives us 1. 1.5 multiplied by 1 gives us 1.5 plus 1 multiplied by 0 gives us 0. So 1.5 plus 0, here is 1.5. 1.5 multiplied by 3 over 8 plus 1 multiplied by minus 1 over 4 gives us 5 over 16. 1.5 multiplied by minus 1 over 4 plus 1 multiplied by 1 over 2 gives us 1 over 8. 1.5 multiplied by 2 plus 1 multiplied by 2 gives us 5. So after getting your Zj values, the next thing to do is Cj minus Zj. 1 minus 1 gives us 0. 1.5 minus 1.5 gives us 0. 0 minus 5 over 16 gives us minus 5 over 16. 0 minus 1 over 8 gives us minus 1 over 8. After getting your Cj minus Zj value, the next thing to do is test for optimality. An optimality condition for maximization, all Cj minus Zj value must be less or equal to 0. So at this point, Cj minus Zj values are 0, 0, minus 5 over 16, and minus 1 over 8. So we have reached the optimum solution. Therefore, the optimum solution occurred at the point x1 is equal to 2, s2 is equal to 2, and the optimum condition at that point is 5. Okay guys, at this point, if you haven't subscribed to my channel, consider subscribing now and turn on the bell notification to get notified anytime I drop a new video. If you have already subscribed, I want to say a very big thanks to you. If you enjoyed the video, consider giving it a thumbs up and make a comment. You can let us know what video you would love to see next. See you in the next video.